Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from autumn 2022. This paper is worth 120 marks in total, and this is the 6th video of 6. It will focus on questions 22 to 24, which account for 20 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 22. Circle the correct conversion of 7 metres cubed to centimetres cubed. So if I was going from metres cubed, ignore that. If I'm going from metres to centimetres, I would multiply by 100. But I'm going from metres cubed to centimetres cubed, so I need to multiply by 100 cubed, okay? So to convert 7 metres cubed to centimetres cubed, we're doing 7 times 100 cubed. So do that on your calculator. 7 times 100 cubed, which is 2, 3, 4, 5, 6. So that's 7 million. So make sure we're doing the correct one. Part B, the diagram shows a shape made from a trapezium and a circle. So we've got a trapezium and then we've got a circle. The parallel sides of the trapezium are tangents to the circle. So we can see here that they don't cut through the circle, they just touch it at a point. The diameter of the circle is 30 centimetres, and that's labelled on there for us as well. The ratio of the white area to the shaded area is as follows. So white area to the shaded area is 1 to k. Find the value of k. Show all your working and give your answer to one significant figure. Okay, so first of all, we are working with area. So I'm going to start by finding the area of the trapezium, the area of the circle, because that's going to help me and that's going to get me some marks. Okay, to find the area of the trapezium, I add the two parallel sides together. So I'm just going to put trapezium here so we know what we're working with. So add these two parallel sides together. So 62 plus 79. Then I multiply them by the height, so the distance between them. So 141, don't know why I'm writing a divide there. That's my brain. 141 multiplied by 30. And then I divide by 2. So this is the area of the trapezium. Okay, area of the trapezium. I'm now going to do the circle. So the area of a circle is pi times the radius squared. So we're doing pi times, the diameter is 30. So the radius is half of that, which is 15. So I'm doing pi times 15 squared. So pi times 15 squared is 225 pi. And I'm going to leave that as 225 pi to start with, so that I'm not dealing with what is quite a messy decimal. So I have the area of the trapezium and I have the area of the circle. Okay, now we're going to deal with this ratio. So the ratio is the white area, the area of the circle, to the shaded area. I don't know the shaded area yet, but I can find it. The shaded area is the area of the trapezium, subtract the area of the circle. So the shaded area is 2,115, subtract 225 pi. So that's 1408.141653. So that's the shaded area, okay? So the area of the circle, so the white area of the circle is 225 pi to the shaded area, which is 1408.141653. Okay, we need the value of k. So this is worth 1. So what we would do is divide by 225 pi. So I'm going to do the same on the other side. So this answer in my calculator divided by, okay, is 1.992119293. Okay, so we want it to one significant figure. So this is k here, remember, that's the part of the ratio to one significant figure. So The first significant figure is the 1, but the value after it can change it, okay? That 9 is 5 or above, so that is going to go up by 1. So our ratio is 1 to 2, so K equals 2. And that's our final answer. Question 23a. Solve 5x add 4 equals 2x add 6. So we know that I like space to do this, so I'm going to copy it here. So we are solving for the unknown variable, which is x. X appears on both sides. So the first thing I need to do is eliminate the smallest lot of x. So we've got 5x and 2x. Both of them are positive. 2x is the smallest term that has our variable in it, so I'm going to eliminate that. So it's a positive 2x. I know it's positive because there's no negative sign. So to eliminate it, I need to subtract 2x. When I subtract 2x from the left-hand side, 5x subtract 2x is 3x. The 4 stays there. I've done nothing with that. I'm only dealing with the x terms. When I subtract 2x from the right-hand side to balance the equation, that eliminates the 2x and just leaves me with 6. Now I've got a 2-step equation here, guys. So the next thing I'm going to do, I'm aiming to isolate the x term. So I'm going to eliminate the positive 4. The opposite of adding 4 would be to subtract 4. So the left-hand side subtract 4 leaves me with 3x. We eliminate that plus 4. But I need to do the same to the right-hand side to balance the equation. 6 subtract 4 is 2. Remember, you can do all of this in your calculator if you need to. Now we have a 1-step equation. This is 3 multiplied by x. The opposite of multiplying by 3 would be to divide by 3. So 3x divided by 3 gives us x on its own, isolated. We've got to do the same to the right-hand side. So 2 divided by 3. I'm just going to write as a fraction 2 over 3. I don't need to write it in any other way. It's not asked for it as a decimal or anything. So that's my final answer. Part B, solve. 4x subtract 3 is greater than 17. So 4x subtract 3 is greater than 17. I'm going to solve this like a normal equation, but instead of writing an equal sign, I need to write that symbol there. So we're aiming to solve for x, okay? So we're isolating the x term. So the first thing I'm going to do is eliminate that negative 3. The opposite of a minus 3 is to add 3. So when I add 3 to the left-hand side, I have 4x. The negative 3 is eliminated, so then we are greater than, but I need to add 3 to the right-hand side, so 17 plus 3 is 20. Remembering to keep that symbol exactly as it is, guys. Now we have a 1-step equation. This is 4 times x is greater than 20. The inverse of multiplying by 4 is to divide by 4. So if I divide by 4, 4x divided by 4 is x. So I've isolated x on its own. I've kept my symbol the same, but I need to divide by 4 on the right-hand side to balance the equation. 20 divided by 4 is 5. X is greater than 5 is our whole answer, guys. That needs to be written. If there's an answer line, it's got to be written x is greater than 5. All 3 parts need to be there. Part C, solve the following simultaneous equations. Use an algebraic, not graphical method. You must show all you're working out. Okay, so when I'm solving simultaneous equations, I'm going to compare the variables and see if they have a matching coefficient. So I have 5x and 1x. Their coefficients doesn't match. That's 5, that's 1. I have minus 2 and minus 1. Their coefficients don't match. This is a minus 2, this is a minus 1. So I need to make a coefficient match so that I can eliminate one of these variables to start with. So I'm going to multiply this equation by 2. So when I multiply this equation by 2, everything gets multiplied by 2. So x times 2 is 2x. Minus y times 2 is minus 2y. And 5 times 2 is 10. And then I'm just going to write this equation above. I don't need to change this equation because if you look now, guys, the coefficients of my y terms match. It doesn't matter what the signs are, but both y terms have a 2 as a coefficient. So this is good. Now we're going to eliminate the y terms, the y variable, because that's the one that has the same coefficient. So I'm going to do a sum here, but I need to look at the signs to see what sum I do. Okay, if the signs are the same, I need to subtract my equations to eliminate the variable. Okay, so I'm subtracting. 5x subtract 2x is 3x. Negative 2y subtract negative 2y becomes negative 2y plus negative 2y. So they are eliminated. And then 16 subtract 10 is 6. Now we've got a one-step equation. 3 multiplied by x is 6. The inverse of multiplying by 3 is to divide by 3. 3x divided by 3 is x. Do the same on the other side to balance the equation. 6 divided by 3 is 2. So x equals 2 is one of our solutions. I'm making that clear because I don't have a line for x and y here. So I'm making it nice and clear there. Now that I've found my x value, I can use that and substitute it into one of these equations to find y. I'm going to go with this equation here. So x minus y equals 5. I know x is 2. So 2 minus y equals 5. I've substituted that 2 in for the x. Okay. Now what I'm going to do is I'm going to isolate the y term. So I'm going to eliminate this 2 to start off with. It's a positive 2. I know it's a positive 2 because there's no negative sign in front of it. So the first thing I'm going to do is subtract 2. When I subtract 2 from this side, it eliminates the 2, leaves me with minus y. I need to do the same on the other side. Don't forget, 5 subtract 2 is 3. Now, what you need to be careful of here, guys, is that negative sign. We don't want negative y. We want positive y. Okay? So this is negative, and that's technically a 1. So we've got negative 1y. So that's negative 1 multiplied by y. So what we need to do is divide by negative 1 to do the inverse. So negative 1y divided by negative 1 is y, but we need to do the same on the right hand side. So 3 divided by negative 1. If you're not sure, do this on your calculator, guys, because it's easy to make a mistake with negative. So 3 divided by negative 1 is negative 3. So y is negative 3. I'm going to highlight that because we don't have a separate answer line for those. Question 24. So we have a diagram here, not drawn to scale, so we can't measure anything directly from it. So the diagram shows a rhombus, A, B, C, D. So A, B, C, D, this is a rhombus. Now a rhombus tells us that all of these sides are exactly the same size. Okay, so be aware of that just in case it's helpful. AC and BD intersect at E. So the line AC and the line BD intersect at point E. The length of AC is 12 centimetres, so the line A to C is 12 centimetres long. BCE, the angle is 35 degrees. So BCE, this angle is 35 degrees. Find the perimeter of ABCD. So we want to find the distance all the way around the outside of this rhombus. Now, the helpful thing here is it's a rhombus, so all 4 sides are the same. So what I'm going to do is I'm simply going to work with one of these triangles that's been formed because all 4 sides are the same. So these triangles must be congruent triangles. So I'm going to work with this triangle here because this is the one they've labelled my angle in. Now, where AC and BD intersect forms a right angle. So this is a right angle triangle. Okay, I know this other angle, but I also know what the base of the triangle is because E is the midpoint, A to E, E to C, all the way is 12. So that must be 6 centimetres to start off with. So what I'm going to do to make things a little bit clearer is I'm just going to sketch this right angle triangle that I'm using here. Okay. So we have a right angle, we have 35 degrees, and we know that this is 6 centimetres. So I've just pulled that triangle off. Now we're going to find the hypotenuse, the longest side, because that's one of the sides of the rhombus, and I know that all 4 sides are the same, and I need to add all 4 sides for the perimeter. So we're going to find this side. So we have got a right angle triangle, a length and another angle. So we're going to be working with trigonometry, guys, okay? So let's start by labeling the triangle. So opposite the right angle is always the hypotenuse. Opposite the other angle is always the opposite, which means this is the adjacent side. Now have a look at which sides we have information for. So we know the adjacent side is 6 centimetres. We are looking for the hypotenuse, that's x. We're not interested in the opposite side at all. We're interested in the adjacent and the hypotenuse. So you may use SOHCAHTOA. It's the cosine ratio that deals with the adjacent and the hypotenuse, guys, okay? So we're working with cosine. So we're going to say that the cosine of our angle 35 is equal to our adjacent over our hypotenuse. So all I'm going to do at this point is substitute in what I know. My adjacent is 6 centimetres. My hypotenuse is the value that I'm looking for. Okay, if you're comfortable with algebra, you can rearrange this equation to solve for x. If you're not comfortable with algebra, we're going to use this formula triangle to tell us what to do next. So we're looking for the hypotenuse. If I cover up the hypotenuse, I'm doing the adjacent divided by cosine. So the adjacent is 6, so x is equal to 6 divided by cosine of the angle. Okay, these things here are what get you marks. So keep these in here to show that you understand how trigonometry works. But if you struggle with algebraic rearranging, use your formula triangle to help you. So I'm going to pop this into my calculator. So I'm going to put it in as a fraction, 6 over cos, and then it's 35, close my bracket. So x is 7.324647533. Okay, so that's one side. That's this side of my rhombus. I want the perimeter, so I want 4 lots of that. So I'm going to do the perimeter equals 4 times 7.324647533. I left that in my calculator because I didn't want to type that all back in again. So I'm going to simply press times by 4. So that gives me 29.29859013. I've written it all out here. There's not a lot of space on there to write it. They don't tell me how to round it. So I'm just going to do it's 29.3 to 1 decimal place.